Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into some test corrections here on graphing quadratics, okay? All right, there's a lot involved here, so I would suggest that you guys take out your notes on Unit 7 first, okay? So all notes on Unit, 7. And in particular, I went over lesson 7-6, Part C. All right, so find your lesson on 7-6, Part C. That is a critical one, and that goes over a lot of different concepts that's involved. But this here, number one, I would say that this is section 7.7. This one here is 7-8. All right, and I'll kind of clue you in so you guys can use your notes effectively. So have this side by side with your notes. It will make more sense because we've done all this stuff before. And again, find your notes on 7.6c. That was a big important one here. All right, and I'll try to kick in the calculator when we're ready here. But let's do it all by hand. All right, we're going to convert each to Vertex Form. So we need to know what that is first. So let's write that down. Okay, y is equal to a times x minus h, quantity squared plus k. There's your Vertex Form. And notice that these are in standard form. Okay, this should be obvious by now since I've covered it for the last, I don't know, 7 lessons the last 3 weeks. Okay, we've been spending 3 weeks on this quadratic unit. All right, so let's get started. Let's take it down here and let's work on this. Let's use completing the square technique. So y equals x squared minus 8x plus 20. First thing I got to do is get this constant on the left hand side. All right, y is equal to, y minus 20 is equal to x squared. I'm sorry, you know what I'm going to do is I'm going to leave room to complete the square here. So plus blank is equal to x squared minus, come on Ainsworth, it's early in the morning here, I got to get warmed up. All right, minus 8x plus blank, here we go. So you got to complete the square here to make it factorable, to get it in vertex form. Okay, that's what the completing the square technique is used for. So let's write that down. So complete the square. And as you guys know, it's always b divided by 2 quantity squared when the lead coefficient is 1. All right, the lead coefficient must be 1. And it is in this case right here. A is 1. A equals 1 is, it's 1x squared right there. So if the lead coefficient is 1, you're allowed to complete the square. So we're going to take b, which is negative 8, all right, and divide it by 2 and square it. That's negative 4 squared. All right, and obviously that's 16. Now I'm going to add 16 on the right, and it's not affected by any lead coefficient here because the lead coefficient is 1. So since I added 16 on the right, I add 16 on the left to balance out. And you can combine like terms right here. The minus 20 plus 16 is a minus 4, so we got y minus 4 is equal to all of this right here. And you want to factor. Okay, so what you know is multiply to 16 and add to negative 8 right here, and guess what? It's right here. Okay, I keep telling you guys, the number that you write down here, which is half a b, is always the number used in your factoring. All right, so you're going to factor by grouping. You're going to split that middle term. Your minus 8x is the same as minus 4x minus 4x. That's a minus 8x. So I'm just rewriting the function, not changing anything. Okay, I'm just rewriting the function. And then if you use a little bit more factoring here, you got to factor out of the first group here an x. Factor out a negative 4 out of the second group. All right, check your work as you go. On the second group right here, negative 4 times x is negative 4x, and negative 4 times negative 4 is positive 16. And so you have y minus 4 is equal to, probably a little bit better here, that's supposed to be a 4. All right, the common binomial, let me highlight this so you can see it. Okay, it's x minus 4 right here. So I'm going to start off with x minus 4. So x minus 4 multiplied by the other binomial, okay, the remaining terms basically, right here, x minus 4, okay, x minus 4. And if you go back into Unit 5 when we did factoring, okay, this is what we did. We've been working on this for 3 months straight, believe it or not. All right, and that is y minus 4 is equal to x minus 4 quantity squared. And if you add 4, your function looks like this. x minus 4 quantity squared plus 4, because you have to add 4 to both sides. So my vertex right here, if you compare, it's x minus h. And I have x minus 4, so h is 4. And k is 4. So we have 4 comma 4. A is 1. A equals 1. That tells you that it opens up versus down. So it opens up, and you have a minimum versus a maximum. All right, so we plot 4 comma 4, which is right here. Okay, V is 4 comma 4. Draw the line of symmetry to help you plot and reflect, as we always do. All right, and the axis symmetry right there, okay, is x equals 4 because it goes through 4 on the x-axis. It's as simple as that. You look at the x-axis, you see where it intersects, and it goes through 4, so the axis symmetry is x equals 4. And then use your parent values for a equals 1. All right, and the parent values, let's get some room here. The parent values, all right, for the parent function a equals 1x squared, looks like this. So we have 1, 2, 3. So when you the parent function is y equals x squared, so you got to square these. 1, 1, 2 comma 4, 2 squared is 4, 3 squared is 9. So I got to go right 1, up 1, and then reflect. Right 2, up 4, and then reflect. All right, and then you draw your function. Okay, you draw your graph for your parabola. Okay, quadratic functions are smooth U-shaped curves called parabolas. They're parabolic. All right, parabola. All right, it's a smooth U-shaped curve, and it gets wider as it goes up. All right, and there you go. Then if you check it here, let's just go in the back here and check. Come on, there we go. Notice the vertex right here is at 4 comma 4. Right 1, up 1, right 2, up 4, and then reflect. Okay, so you can see the graph pretty easily. Okay, so here we go. That's number 1. Pretty simple. Oh, range, all reals, always for all polynomial equations. The range is all reals. It's for all polynomial functions. So all quadratics. Okay, I'm talking squared functions, which are called quadratics, cubic function, 3rd degree, 4th degree, 5th degree. It doesn't matter what the degree is. For all polynomial functions, the domain is all reals. You're going to see that again in Algebra 2 and pre-calc and calc, and the list goes on. Okay, so now, okay, A is 2. All right, A is 2 right here. All right, so switch to section 7, 8 in your notes. You gotta. Okay, so over here we have y equals 2x squared, all right, minus 12x plus 22, and you got to subtract 22 to start, just like I did on the previous one, and we have y minus 22 is equal to 2x squared minus 12x. Now, since a is 2, you got to distribute it out, because you can't complete the square if the lead coefficient is not 1, and it's not 1, it's 2, so you got to distribute it out. So 2 times x squared minus 2 times negative 6 is negative 12, so that changes. When you factor out a 2, you got to factor out a 2 out of both terms, right? Okay, and then plus blank. So the lead coefficient must be 1. Okay, lead coefficient must be 1, all right, to complete the square. If you look at your notes, we did that and we wrote it down. Okay, lead coefficient must be 1 to complete the square. Key concept right there. Again, look at your section 7, 8 notes for that. So now we got a complete square. So here we go. B is negative 6. So negative 6 divided by 2 quantity squared equals negative 3 squared, or 9. But you got to be careful on this one because the 9 is being multiplied by the lead coefficient of 2. So really we added 18 here. So to balance out, we got to add 18 on the left. All right, you got to think about what you're doing. All right, you didn't add 9, you added 2 times 9, which is 18. All right, so we got a 18 minus 22 is a minus 4, so we have y minus 4 here is equal to 2 times all of this, and you got to start your factoring again. So here we go. So what two numbers multiply to 9 and add to negative 6? Guess what? It's right here. It's negative 3. So the two numbers that multiply to 9 and add to negative 6 is always half of b. It's always right here, this number. That's why I suggest to write down your side work. It will always be that. And you're going to see that in the result here. You're going to see a -3 in the result. It's always part of the vertex form. So we're going to have x squared minus 3x here, plus 9. Factor by grouping. Okay, just split the middle term right here. Minus 6x is a minus 3x minus 3x. We have y minus 4 is equal to 2 times, all right, excuse me, got to factor out the x right there. So x times x minus 3, and then factor out the -3, and then minus 3 times x minus 3 again. All right, and so our two binomials here are going to be x minus 3 when you finish your factoring. So 2 times x minus 3 times x minus 3. These binomials will always be the same. And notice the number again, -3. This number will always be half a b. That's how people skip steps, all right? Because they know the pattern. So y minus 4 equals 2 times x minus 3 squared. And so my final result, I'm going to put it in red up here, is y is equal to 2 times x minus 3 quantity squared. If you add 4 to both sides, you're going to have a plus 4. So your vertex is 3, 4, where a is 2. And so we have to switch parent values. Now the parent values are twice the previous parent. So instead of 1, 4, 9, I'm going to have 2, 8, 18. So my parent values for this, 1, 2, 3, so 2x squared. You square and then multiply by 2. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. So the parent values. And if you look in your notes, these are the values we used. So we plot the vertex 3, 4, which is right there. Okay, so 3, 4. Let's go ahead and draw the line of symmetry, which is x equals 3. Why? Because it goes through 3. Look, okay, it's pretty simple. And then you go right 1 up 2, right 2 up 8. So right 1 up 2 this time. Okay, right 1 up 2 and then reflect. Right 2 up 8, all right, which is right about up here, and then reflect. And then you draw your curve. Okay, and it's more narrow because B is, A is 2, and that changes the shape of the parabola. All right, so this parabola is more narrow than the previous one because A is 2 and not 1. Changes the shape. The domain is the same for all parabolas. Okay, it's always all reals. Oh, I forgot the range on the previous one. I'll do that here in a minute. All right, this is a minimum, okay, because it's a low point at 3, 4. Now, because these are minimums, the minimum y value on this graph, as you can tell, all right, it's obviously 4. It doesn't go any lower than that. All right, so the range, the set of y values here, range is always the set of y values. Y is always greater than or equal to this 4 value because all these y values on the curve are obviously above 4. They're greater than or equal to 4. And I have to finish the previous one here too. Same thing here, the lowest y value, all right, on the parabola is 4. So the minimum y value, min y value, okay, is equal to 4. So the range must be greater than or equal to 4 because the parabola lies above it, not below it. And the x-axis symmetry in this case is x equals 3 because it's a vertical line going through 3, whereas the previous one is a vertical line going through 4. So on both functions, just so happens to be the same, the range is y greater than or equal to 4. Okay, because that's the lowest point on the curve in respect to the y values. All right, so that's the first part. Okay. Now the easy part. Okay, so these are already in vertex form. So we have y equals a times x minus h squared plus k. So the vertex on this one, here's h and here's k, which is 2, 2. All right, a is 1, a equals 1. That tells you that it opens up versus down. And we have a minimum in this case. So we plot 2, 2. All right, and then we go right 1, up 1. All right, reflect, right 2 up 4, and reflect. All right, so then we draw our curve, No. Smooth U-shaped curve. No. Okay, there we go. Got to put the sound effects in. All right, domain all reals. As I keep saying, range, the lowest point on the curve is 2, so it's going to be y greater than or equal to 2. Axis symmetry goes right through 2 on the x-axis, so it's x equals 2. All right, no x-intercepts on this case. All right, and the next one, we've got a little different function here. Y equals a times x minus h squared plus k. Now here, a equals -1, so it opens down. All right, h is -3 because this can be re-expressed as x minus a -3. All right, x minus -3 is the same as x plus 3, so h is negative. In this case, and k is -2 because it's a -4 instead of a +4. So the vertex here is -3, -4. And because it opens down, we have a max. So we plot -3, -4, which is left 3 down 4. Draw the line of symmetry again. Start plotting. Okay, now a equals -1. All right, so if the parent values here is -x squared, all right, because a equals -1, over here a equals 1. And if a equals 1, the parent values x, x squared, 1, 2, 3, it would be 1, 4, 9. So that's why we went right 1 up 1, right 2 up 4, and right 3 up 9 if we could. Here you got to go down. So for 1, 2, 3, 1 squared is 1 times -1 is -1, and then you get -4 and a -9. So we got to go right and down, right and down. Okay, so we go right 1 down 1 because this parabola opens downward. Right 2 down 4. All right, and then you plot and you reflect the point as we always do. So let's see here. It's going to draw a smooth U-shaped curve. And then, answer all the following questions. So all reals for the domain. Now this is a max, okay? The max y value is right here, okay? Max y value. Can't even spell this morning. Okay, can't even write. So max y value, there you go. All right, now max y value is -4, so the range is less than or equal to -4 in this case. And then axis symmetry goes through -3 on the x-axis, so it's x equals -3. All right, and that's all there is to it. Okay, moving on. Okay, how do you find x-intercepts? Well, since we started in the very beginning right here, let's see here if I have my instructor's notes here for all the sections. Okay, so let's go back to the very beginning, section 7.2. Okay, when I first started teaching and going through the parabolas here, let's see. There we go, come on. Takes a second for this to pop up. There we go. All right, so when I first started teaching how to graph a quadratic function here, what was I doing here? We had to find x-intercepts. Okay, and check it out. Oops, sorry. All right, now to find the x-intercepts is a simple game. You got to figure out where the parabola crosses the y-axis. And so we talked about how we set y equals 0 and solve for x. This is section 7.2. All right, so since the beginning of the unit here, the x-intercepts are where the function or the graph crosses the y-axis, and that's where y equals 0. So anytime you want to do that, you set y equals 0 and solve for x, whether it's by factoring or by completing the square or square roots, depending on the function. Okay, so in this case, let's go back to your test here. All right, how do you find the x-intercepts? Well, you set y equal to 0 and you solve for x. So let's do that. Okay, let's write that down. So set y equal to 0 and solve for x. That's what we've been doing for the last 2.5 weeks. All right, you have to understand your methods. Okay, so we set y equal to 0, so 0 equals, okay, v squared plus v minus 2. Now you can try factoring, completing the square. You can try quadratic formula. You can use any method you want. All right, that's appropriate. If you factor, then you got to figure out, okay, what two numbers multiply to -2 and add to 1? Well, let me see. -2 times 1 is -2, but they don't add to 1. So this has to be positive, and this has to be negative. 2 times -1 is -2, and 2 plus -1 is 1. So this is factorable. So I'm going to do it by factoring, although you don't have to. You can choose any method you want. Okay, so here we go. So we've got 0 is equal to v squared plus 2v minus 2. And then you factor the v out of the first group, v plus 2. Factor out a -1 out of the second group, v, you get -1 times v plus 2 again. You got to get to the zero product stage, so you got to keep factoring. Okay, now this is the zero product. And here's the idea. When you have something times something equals 0, one of these has to be equal to 0. So you set v plus 2 equal to 0, solve. You set v minus 1 equal to 0 and solve. And you get v equals -2 here, and you get v equals 1 here. So the x-intercepts are -2 comma 0. All right, and the other one is 1 comma 0. So 1 comma 0. Why? Because y equals 0. Right? You let y equal 0. So here are the x-intercepts. All right, that's the first one. Second one, same thing. Okay, you got to set y equal to 0. So here we go. So 0 equals something. All right, 2v squared minus 11v plus 14. You can solve this any way you want. Quadratic formula, completing the square, you name it. I think this might be factorable though. So if you multiply 2 times 14, you get 28. And so what two numbers multiply to 28 and add to -11? And since the factor pairs of 28 are 1 and 28, 2 times 14, 4 times 7. Notice 4 plus 7 is 11, so if you make them both negative, all right, you can make this work. This is factorable. So why don't you solve it by factoring? Or use it completing the square, or quadratic formula. You could use any method you want, all right? Any method you want. So I don't care, just pick a method. I even let you use your notes on quadratics, so you can take your Unit 6 notes out, which is what I had you guys do. So Unit 6 notes. Okay, so let's start factoring. So 2v squared minus 4v minus 7v plus 14 equals 2, and let's factor out a 2v. So 2v times, all right, v minus 2, factor out a -7, and you get v, excuse me, v minus 2 again. And so 0 equals v minus 2, which is your common binomial, right? That's your common factor, your GCF in this case. All right, there you go, multiplied by your remaining terms, all right, 2v minus 7. So what does that look like? So we have 2v minus 7 here. Now you have another zero product. And if you use your notes, let's see, section, oh, it's section 6.1. So section 6.1 notes, all right, factoring notes. So take these out, guys. Unit 6, section 1, solving by factoring. All right, you set each equal to 0. And you get v equals 2 here, and you get v, well, let's solve this one. All right, let's add 7. You get 2v equals 7 divided by 2, and you get v equals 7/2. So your x-intercepts, all right, 2 comma 0. All right, and the other one would be 7/2, which is 3.5 comma 0. Here and here. Okay. So again, I did this by factoring, but you could use a quadratic formula. You could use completing the square. It doesn't really matter. You can't use square roots because you have a b equals, you have a b term. You have a middle term here, so you can't use square roots to solve these equations, but you can solve them by factoring, completing the square, and the quadratic formula. It's up to you. Okay. Now the next one here, we got to identify the a value. Just fix that misspelling right there. Figure out the a value. Here a is equal to -2. Okay, find the vertex. That means you got to compare it to vertex form, which is in vertex form. So a times x minus h, quantity squared plus k. So the vertex here is -4, 4. Okay, a equals -2. Let me see, -4, 4. A equals -2. So this tells you that it opens down because a is negative. Okay, so when you plot left 4, up 4, when you plot the vertex right here at -4, 4, this prob opens down. All right, and the parent values. Parent values are your 2x squared or -2x squared. So 1, 2, 3. So 1 squared is 1 times -2 is -2. 2 squared is 4 times -2 is -8. 3 squared is 9 times -2 is -18. So those are your parent values. So you're going to go write 1 down 2 and reflect. Write 2 down 8 way down here and reflect. Okay, so here we go. So just plot that parabola here. Okay, on this one here, I want you guys to look at your section 7.6c notes. Okay, so first of all, the domain's easy. It's always all reals. The range, this is a max y value. There's your max y value, so it's less than or equal to 4 in this case. X symmetry goes through -4, so x equals -4. So far, pretty easy here. But the x-intercepts, not too easy. Okay, it's between -5 and -6, and between -2 and -3. All right, and I asked you guys to solve them. Okay, and I showed you how to do this. All right, you set y equal to 0 and solve for x. So let's take this down here. All right, you set y equal to 0. All right, and solve for x. Let's do it. It's the same method for the entire unit. Okay, 0 equals -2 times x plus 4 squared plus 4. Well, you got to isolate the square term. So in this, you use your section 6.2 notes. So let's write that down somewhere. All right, refer to section 6.2 notes. All right, solving by square roots. So let's do that. So let's subtract 4. All right, you get -4 is equal to -2 times quantity x plus 4 squared. You got to isolate first before you root. So we get 2 is equal to x plus 4 squared. And now we square root both sides. Okay, and what do you get? Well, you get plus or minus rad 2, all right, is equal to x plus 4. And then finish up at a -4. And you get -4 plus or minus rad 2 is equal to x. So my x-intercepts right here, let's just finish up, are -4 plus rad 2 comma 0, all right, and -4 plus, excuse me, minus rad 2 comma 0. Notice y equals 0, right? So those are my intercepts, and let's see if they're correct. So I'm going to go to the calculator and do some calculations. I got to compute -4 plus rad 2, and then -4 minus rad 2. So let's pick up the calculator and let's do it. Okay, that's why I gave you guys a calculator, so you can also check your work. All right, and we're going to check our work right now. Okay, so here we go. So -4, all right, plus the square root of 2. All right, it's -2.58, or it says -2.6. -2.6. And then -4 minus the square root of 2. What is that? So I got -2.6 and -5.4. Okay, so here -2.6 is, that makes sense because your first x-intercept is, let's zoom in here. Here's your first one x-intercept, and here's the next one. And So negative 2.6 sounds pretty good. That could be negative 2.6, and negative 5, what was it? Let's get my calculator back here. Okay, so it was negative 5.4. Let's see. That could be it too, right? I mean, just take a look at it, right? Negative 5.4 is between negative 5 and negative 6, and negative 2.6 is between negative 2 and negative 3. Okay. So the results look good. You can even put this function in your calculator, which some of you guys did, and go into trace mode and figure these values out too. I saw you guys do that as well, which is fine. Okay, so here are the exact values. These are the exacts. So that kind of hard. I don't have enough room to write them in there, but okay. So this information right here is here. All right, and let me see. Negative 2.6. Negative 2.6 comma 0 is your approximation. That's this one, and negative 5.4 comma 0 is my second one. Okay, but these are the exact values. Up here, up top, you know, in root form, and your decimals, these are called approximations, right? Because you rounded. All right, so let me label this one. This is what I was looking for here, the exact values. Exact values. Okay? And if you look at your notes, we did this before together here. All right, and we talked about this. We did 3 main examples. In fact, you know, let me pull my notes up to show you guys and remind you guys. So here we go. This is my lesson on 7.6, where we went over in detail how to figure out these exact values. All right, we took a look at an example. It's right up here up top, very similar to the one on the test. We noticed the same thing. We don't know what the X-intercepts are, so we solve for them 2 different ways. We use square roots. We use vertex form and use roots. We also use standard form. We got the same values. We also use the calculators too to check our work and see if it made sense. So the question is, did you study and did you practice these techniques before the test? Did you do that? Only you can answer that. So if the answer is no, then maybe that's why things were difficult on the quiz or the test for you. All right. One must study all material and get ready for the test, all right? You can't just go into it cold, all right? You have to practice all the different techniques, especially on a final exam, okay? Or a chapter exam, even a big quiz like this, you have to go through and go practice all the basics. Just because you learned something a few weeks ago doesn't mean you remember everything today, especially when it covers 2 full units or 2 months worth of work. Okay, you got to practice. Okay, last one here. We've got to take solve this by square root. So let's subtract 4 and let's isolate the square. And by the way, this is section 6.2. Okay, so here we go. We get 2a squared is equal to 150. Divide by 2. And you get a squared is equal to 75. Square root both sides. Put the plus or minus symbol in there. And you get a is equal to plus or minus rad 75. Now the factor pairs of 75 are 1 and 75. All right, 2, that's not divisible by 2 because it's odd, but it ends in a 5. All right, and 7 plus 5 is 12, so it's divisible by 3. 3 times 25 is 75. And 5 times 15 is 75. So we're talking about factor pairs here, which you guys are very familiar with because we've been doing it for the last 3 months. All right, and pick the one that involves the square. So the square root of 75 equals roots 25 times the square root of 3, which is 5 rad 3. So a is equal to plus or minus 5. Let me detail that out again. Root 25 times square root of 3, which means that a is equal to plus or minus 5 root 3. That's 2 answers here. A equals 5 root 3, negative 5 root 3. Okay, 2 results. All right, 2 solutions. not one. Quadratics have up to 2, either 2, 1, or 0 solutions. Okay, and yeah, this is a big quiz, right? Because it covers a big body of material here, 8 lessons in quadratics. And so if you didn't do well, go back through it. Focus on studying better, reviewing better, practicing, okay? Because you not only have to do it, but you have to do it quickly, do it in the right amount of time, all right? Because it's just a quiz, it's not a test, all right? And you had 50 minutes. So there you go, all right? Keep practicing. And again, practice. Repeat each one 2 or 3 times until you can do each one easily, step by step, all right? Perfectly well. You guys got to focus in on your practicing, your studying. And like anything in life, practice through repetition. Practice until the light bulb goes on, until you get it. All right, do whatever you have to do. All right, to fully understand the material and also do it in the correct amount of time. Some of you guys struggle in speed, not just method, but also speed. So you got to work on that through practice, just like you do in sports. Okay, you don't see good athletes just do it once and think they got it. No, they do it like hundreds, if not thousands of times to work on perfection. Okay, well, the same thing here. You guys got to do that too. All right, so do your best. I'll see you in class. Bye-bye. Let me